We should just know. All right, so the top topic here, this is sine and cosine function graphs. Okay. This is so interesting. You have spent 3-4 days, maybe a week, learning unit circle values. If we take that circle and we unwrap it onto an XY chart and plot those points, we get the sine curve. Okay? So it's like unwrapping the unit circle and stretching it out into an XY graph. Okay? So these points aren't random. They're coming from our unit circle values. So I want to start at 0, or this would be 1, 0 on the unit circle, right? Well, sine of 0 degrees or sine of 0 radians is what? What's the y coordinate at this point?
0.
This is 1, 0. So sine of 0 is 0. That's why we plot that point at the origin. So it goes 0, 0. Now, let's increase that to maybe pi over 4. Pi over 4. At pi over 4 theta, what is sine of pi over 4? Square root 2 over 2. Positive, right? Well, that happens halfway between 0 and pi over 2. That means that that's about this value right here. That's that y value. Okay? Your graph skips all the way to pi over 2. So jump up to that quadrantal angle. What is sine of pi over 2? What's the y value of this ordered pair? 1. Isn't that ordered pair located at 0, 1?
Yeah.
So sine of pi over 2 is 1. Notice that when I'm x equals pi over 2, or theta equals pi over 2, the y value there is 1. You see? These aren't random points. And it's not just some curve that oscillates over and over. It actually aligns with the values from the unit circle. Slide out to pi. What's the ordered pair for this number, or for this point? Negative 1, 0. So what's the y value at that ordered pair? 0. Sine of pi is 0. Notice that at pi, this comes back down through the origin. I mean, not through the origin, through the x-axis. Can you see it? Slide down to the bottom here, 3 pi over 2. What's my y value at 3 pi over 2? Negative 1. Oh, makes sense, yeah? And by the time I complete the circle or complete the cycle, I'm at 2 pi. What is sine of 2 pi? Back to 0. So 3 pi over 2 and back to 0. Say it again. It's called a period, yeah. 1 cycle length. Good. Okay, so it says, what's the domain of the sine curve? What's the domain? How far left to how far right? All real numbers. All real numbers. In interval notation, we're going to have negative infinity to positive infinity. And the range here, it oscillates between positive 1 and negative 1. Let's put them in order from least to greatest. Negative 1 to positive 1, yeah. And so we're going to talk about that in a little bit as to why that might be my boundary. Why are those my range lines? Okay. Now we're going to look at cosine under the same kind of microscope. If you wanted to, we could use that circle that I just drew up there. What is cosine of 0 degrees or 0 radians? 1. Notice that cosine intersects the y-axis at 1. That's kind of my starting value, if you will. So I'm going 0, 1. What's cosine of pi over 2? Slide up. 0. 0 at the top. Now cosine goes to the left. At pi, cosine is negative 1. Notice that that's exactly what happens here. When x is pi, cosine's negative 1. And then back down to the bottom, cosine at 3 pi over 2, 0. And cosine of 2 pi, back to 1. Anybody surprised by the way that this picture looks? What I can tell when I start looking at, is it sine or cosine? Because both of them look like this. They both look like waves. We call them sinusoidal functions. Sinusoidal. When I can tell the difference, am I looking at sine or am I looking at cosine? I look at the origin. Sine goes through the origin because sine of 0 is 0. And cosine goes through 0, 1 because cosine 0 is 1. That's how I can tell the difference. I check the y-axis.
There's a 100%, there's like real life application with this.
100% real life application.
Heart monitors.
Pendulum. Or a spring, like a mass spring system. If I have a spring on a like a mass on a vertical spring, right, and I pull it down and I let it go, what's it going to do? Whoop, 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 whoop. And in the absence of air resistance, that just happens forever and ever and ever and ever, right? But if I'm in a situation where there is air resistance, we see something called damping. And so our sine curve, which is supposed to go up and down forever and ever and ever, goes more like, and it kind of converges.
Oh, like
Yeah.
It looks like a doctor's
it
signature.
fades away.
Mm-hmm. Yeah, it kind of fades away.
You can use it to track progress in the computers.
That's called damping when the spring like stops oscillating. It's called damping. Yeah, real life application. Good. All right, moving on. Moving on. By the way, that was all of those notes. Yeah, so we would be done. Anyways.
I'm okay with that. I can't
No,
do that.
we're not. Okay, so here's a check your understanding. After the conversation we just had, explain why the range of both sine and cosine is from -1 to 1. And you can see that, right? We can see it's capped at 1 and it's capped at -1. I can see that function goes between those two values, but why?
Because the radius of the unit circle is 1.
Because the radius of the unit circle is 1. That's the hypotenuse of the triangles, right? Where sine is the vertical leg length and cosine is the horizontal leg length, and the hypotenuse is 1. Well, the hypotenuse, 1, is as long as those triangles can be. The radius is never going to outrun, or the leg lengths are never going to outrun the hypotenuse, right? So when that triangle is fully laid over on its side, the length is 1. That's as long as it's ever going to be. That is the hypotenuse, or that is the radius. Does that make sense? So I wrote down right here the hypotenuse, and Truitt called that the radius. The radius will never be longer or the legs. I feel like we should say the legs will never be longer than the radius. I think I've got my statement backwards here. The legs will never be longer than the radius or the hypotenuse.
So if you have a radius of like 5 on a circle and you want to graph it and put it into a sine chart, then it would go up to 5.
Oh, great question. He says, so if the radius of the circle happens to be 5 and you're going to graph it on a sine curve, then it's going to go up to 5 or down to 5. Wonderful question. We're going to get there. Just a minute. Really good question. All right, so number 2, it says, how many cycles of sine, how many cycles can be graphed on the interval from -2 pi to 4 pi? So I'm going to put a number line here, and I'm going to pretend it starts at -2 pi. And it's going to go all the way to 4 pi.
2.
Ruth called it earlier a period, a cycle. How many?
2.
3. Because what is a cycle of sine? 2 pi. Takes 2 pi to get from start to finish, right? So if I go to 2 pi from 0, that's 1 cycle. If I go from 2 pi to 4 pi, that's another cycle. If I go from 0 back to -2 pi, that's another cycle. So how many cycles?
3.
3 cycles. Very good. Next question, is cosine an even function, an odd function, or neither? And how do you know? Just throw out one. Just try. It's even. How do you know, Jenna? Because if you fold it over the y-axis, it's symmetric. It's symmetric on the y-axis. Here's the rule for that. F of theta is equal to f of negative theta. In other words, whether I go to the right or go to the left, I hit the same y value. Think about it. What is f of pi over 4? Cosine of pi over 4. What is that? It's cosine of pi over 4.
No, wait. Square root of 2 over 2.
Good. And what is cosine of negative pi over 4? So we're talking about cosine of this pi over 4 versus cosine of this negative pi over 4.
Square root of 2 over 2.
Both square root 2 over 2. They're equal. Since they're the same number, and you could have seen that had we graphed the cosine curve, right? Cosine is symmetric on the y-axis, so I'm going to get the same value for y in both places. Good. So it's even. How about sine? Even, odd, or neither? You know, flip a coin back there, Joseph? Odd. Why? Because they're opposite. They're opposite, right? It's symmetric on what? Not the x-axis.
Y.
On y equals x. Good. Symmetric on y equals x. The origin. Okay, so when it's odd, we have f of x is equal to negative f of negative x. So if I go on one side or the other of the y-axis, I should get opposite signs. Same number, but opposite signs. So let's try it. Let's try f of pi over 4. Sine of pi over 4. That's positive square root 2 over 2. How about sine of negative pi over 4?
Negative square root 2.
Negative square root 2 over 2. Right? That's the y value. One's positive, one's negative. They're the same but opposite. That means that the function is odd. Questions on that? Super good work right here. Okay. All right, so let's do a little true-false. This is about cosine. F of x equals f of negative x. True or false? True. We just said it's even. That is true. The graph of f has a y-intercept of 1. Yes. Graph of f is concave over its entire domain. Concave down. So that means that it is down like a frown the whole time. No, that's false. X-axis represents the cosine ratio. That's false. That's false. F of 146 pi is 1. True. Why? It's even. It's divisible by 2. And at 2 pi, I'm at 1. We'll keep you. You can stay. F is undefined for x less than 0. No, I can go to the left. I can go to the left. We said its domain is all real numbers. We can have negative. Questions there? Huh? All done? What time is it? No way. Cheese balls. This guy. Okay, we're going to take some notes here at the bottom that I think are going to help us moving forward with the next page. All right, so for the function, y equals sine of x, things that you already know, okay? For y equals sine of x, the domain, you said was all real numbers, or negative infinity to positive infinity, yeah? Range for y equals sine of x, negative 1 to 1. No questions on that? Okay. The period or the cycle length.
2 pi.
2 pi. Good. And the amplitude, and this was Truett's question, if I have a circle that's radius is larger, does my amplitude change? You bet. What's the amplitude on the parent function for sine? Radius, which is 1. Parent function, we're talking unit circle size. Okay. All of this is going to be the same for cosine of x. They all have the same domain, same range, same period, same amplitude. Okay. Some different thoughts on period and amplitude. This is called the midline of the function. The midline. On the parent function, the midline is the x-axis. Okay. The distance from the midline to the peak. The distance from the midline to the peak. This is called amplitude. Okay, so those of you who have never heard that word before. Amplitude is the distance from the midline to the peak. These are called, they call them peak. They may call it the maximum. I've also heard it called the crest. If it's up top, think of like a wave. This is the crest of the wave. Down on the bottom, they call it the trough. Trough, like something a cow would drink out of. Crest and trough. Okay. The period is the distance from, you can measure it several ways. You have to measure from the same location within the cycle. So you could measure period from crest to crest. This goes all the way across. This would be period. It's a cycle length. That's what it means. You could measure period from trough to trough. So let's say I have another trough over here. I could measure period from trough to trough. They're the same. You could also measure period from the same point on the function to the other same point on the function. Is that what you're saying? Yeah. Okay, so it doesn't have to be from extreme values. It could just be from one point on the function to that exact same point on the next one. Period. Okay? Any questions at all here? Period is also known as cycle length. Okay, so here's what we're going to do. We're going to start translating and dilating and transforming. Cool. Turn the page. Y'all are a step ahead of me today. I'm feeling good about it. Some of y'all are. Some of y'all are 3 steps behind, and that's fine too. I love you all the same. I do. I really do. On the next page, you've got choices A, B, C, D. The name of the game is find a reason for what makes each one different from the other. Okay, so the question is which of these does not belong? I don't think any of them belong. So your job is to figure out what's different, and then you've got to read the problems on, or the functions on number 2. Y'all see these problems down here? And number 3, I want you to get in little groups. I want you to have the richest discussion that you've had all day about trig functions. Ready, set, go. We're going to come back together in, 10 minutes. We'll come back together and recap. 5 minutes. 5 minutes. Ready, break. Okay, so we're going to come back together. Everybody come back together. Y'all are doing so well. I'm so impressed by your conversations. There's a back. We can pause. We'll just finish this page and we'll do the back page tomorrow. All of you who are crying, dry your tears. We'll do the back tomorrow. Okay, so part A here. This function, talk to me about it. I heard so many really good things. Talk to me. Amplitude is 2. Distance from the midline to the peak is 2. Okay, so if it's been stretched by 2, and my y values are located at r sine theta, what does it mean? If my amplitude is 2, then my radius of my circle would be 2. I also heard somebody say insiders lie and outsiders tell the truth. This is a vertical stretch of 2. So which one do you think is A?
Top right.
Top right on your table.
Yeah, that's what
That is A. Good. That is good. Okay, so vertical stretch of 2, so that amplitude, that's going to be the coefficient of your function in the very front. Okay, what if that number's negative? It could flip. It could reflect. Which brings me to part B. Part B, we believe, so we think this one is y equals 2 sine theta. I heard several people say it's reflected. It's reflected over the x-axis. Y equals negative sine x. I agree with that. So that's down here. Kennedy thinks this is also written as y equals negative sine x. True that. Yes. But what else I see is that if they had this sine curve going through the origin, starting this one right here, it's a phase shift. It's actually shifted to the right by how many, Grace? By pi. So we could also call this y equals sine of x. Why minus pi?
Because shifted to the right.
Because insiders lie. Insiders lie. So this actually went right pi. So if I had started my function right here, you feel like that would be a good sine curve? Right? Would that look like the parent function? If it had its origin right here? Can you tell that that's a whole shift off of that by pi? Okay, so that's all that happened there. And Kennedy thinks those could be equal. What do you think? Yeah, because I really thought it was y equals negative sine x until that wasn't an option down here.
Okay.
So I would say this one is B. Okay. Moving on. So this one's amplitude is still 1. Amplitude hasn't changed, but the period changed. It kind of got scrunched in here like an accordion. Its period is shorter. So instead of affecting the vertical dilation, this is a horizontal stretch. Insiders lie, right? It's got to be inside with x. This is a change. It should be 2 pi. The period should be 2 pi. But instead, it's only a half length, pi. Horizontal dilations are backwards. So this 2x decreases the period by half. It's now a half length. You understand? So this one is C. And then the last one, I heard everybody got this one, went up 2. Because outsiders tell the truth. So this is also a shift, a translation, but because it's up 2, we could say sine x plus 2. Okay? Question. I need you to think of this. What's the range of this new function after it's been moved up 2? 1 to 3. Right? It still has the same amplitude. Its amplitude is still 1. But its range has clicked up a couple of notches. Okay? Any questions on that? So we're going to deep dive here tomorrow. I want you to come back ready to make that happen. No homework tonight. You're welcome.